Oh, yeah, I did not get a chance to update these, but we went to Battelle this Saturday, and it was pretty cool. We learned about how to mess around with, or how to reverse engineer video games, like MMOs, and see if we can exploit vulnerabilities that are built into the game. And that's actually what we're going to go over tonight. Chris is going to explain some of that. And this Saturday we are going to have a cookout, I believe, in Burnett Wood.
We're gonna cookout at Burnett Woods, BYOB. You know, we'll have some good cookings, some good meats. You know,
sounds unplanned.
Huh?
Sounds unplanned.
It is planned. John has put together. We'll probably be putting out another message in the general channel. So join our Slack if you want to know what's up. If you don't join our Slack, you're gonna find out and we'll hunt you down. And then compromise your computer.
Is that a threat? Yes. Do we need to go over certified ethical hackers?
All right, but anyway, so we're just gonna skip past that, and yeah, Chris, you want to go ahead and jump into stuff?
Boo, Chris, boo. Boo.
You would like.
Heckling you, Chris.
Good.
Pressure's on.
Honestly,
All right, so I'm actually going to rewind. We skipped news last week, but I think everyone knows that Julian Assange got arrested. He got kicked out of the Ecuadorian embassy. They welcomed him in the UK police, and they literally drug him out. So that's a pretty high-profile event in terms of cybersecurity stuff going on. Less high-profile, this one. This is the guy who found the kill switch in WannaCry, and he was arrested in 2017 DEF CON, and this is only just coming out now, but he was basically picked up on the way out by the FBI, and he was apparently the guy who made Kronos, and then they arrested him for it, and he pleaded guilty. Kronos is a banking malware Trojan, so basically what's this on a system, whenever people do online banking, it just steals all their information related to their bank.
You wouldn't download a Fancy Bear.
Yeah. You wouldn't download a Fancy Bear. Does anyone remember you wouldn't download a bear? You wouldn't download a Fancy Bear.
Do you know what Fancy Bear is? It's a joke based on a CrowdStrike's naming convention, Advanced Persistent Threat Fancy Bear.
Which is Russian, right?
Yeah.
Which is people attribute to Russia, but
It's
anybody could
expected
try
to be
look
the
like
Russian
Russians.
government in some sort. So you wouldn't download a Fancy Bear.
Russia.
All right, that's it for news this week. I got exams. All right, so we're doing Pwn Adventure 3. If anyone's not seen this, this is a CTF that is in the form of a video game, and you have to exploit the game in order to get any of the flags. So this is their logo. Pony Island. Go to their website and download it if you don't have it already.
We're my little funny club now.
Game Weenie, get your laptop out.
Fine. I'm gonna show you some shit up. So I think this game is easier to reverse engineer on the Windows laptop than Linux, but Linux works just fine too.
Is it?
Yeah, because when you're opening up the executable on Windows, like
the DLL and Ghidra, or just actually running it?
like Ghidra or IDA or whatnot, you're just simply the EXE, Windows EXE.
Well, I spent 16 hours on it on Linux, so we're gonna do that.
Yeah, Linux is the way to go. But no, according to Aaron, it was easy. McCanty. Because
I saved
some of the
Patel
values got
slides.
loaded in.
All the Patel slides we've ever seen are now in our drive.
What?
All the Patel slides we've ever seen, including how to set up this game on the server, is now in our drive.
Yeah. Dope.
Alright. Does anyone not know the name already? Pwn Adventure? Download it or else. Okay, we're moving on. So when you download the game, it should have to you actually download the launcher. This is true for most games, how this behaves. You download the launcher, you run it the first time, the launcher downloads the game for you. And it's usually like a huge amount of information. So let's go in here real quick. When we first start the launcher, it looks like this. I have already downloaded the game, so there's no updates waiting for me.
So to download the game, do we all have to download it, or is there a drive link or somewhere that we should go to get it?
There's the website that I just had up.
Pwn Adventure 3.
PwnAdventure.com. That is the website.
But what about the files that Battelle gave us?
That was the ones from the website. They were just on a flash drive, so you didn't have to download it.
Well, right, but how are everyone else supposed to download?
You connect to the site.
From the website.
Oh.
Actually, the website didn't come with the proxy or the parse.
That's what I'm talking about.
I'll distribute those separately.
Put them in the Slack
I'm
channel.
just saying that's where the confusion's coming
Someone
from.
else. Someone else. Put
Drop them in Slack, goddammit.
I'm not there yet. Okay. It looks like this. And you can repair your install. Don't do that. Alright, you hit play. It closes the main executable and it launches a new one, which is the actual game itself. You can see my terminal is actually returned here. So that's indication that it started another binary entirely. It'll be important in a little bit. One day it'll load. If you're playing on Linux, this game is slow as hell, and all the buttons are significantly offset from where the mouse pointer is. Today we did this in Franco's class, and his mouse pointer was easily half an inch under the button for him to press it. It was a mess. Alright. So, when you get this installed locally, you're not going to have a server unless you went to Battelle, and then you can steal theirs. So you can just hit offline play. Your screen breaks, apparently. Oh god.
I want to go into options first.
Options?
Sometimes I'm pretty sure the default is
Oh, yeah.
high.
You want to hit low on both of these. You can hit fast. It will be significantly faster if you're on a really bad laptop. However, the game will get unbelievably dark and you can't see anything.
It also looks like mud.
It looks like
The whole game
literally looks like mud. If you play it on high on a Windows desktop,
Depends if you have a graphics card or not.
it looks pretty good. All right, this is our character. All right, so when you first start, you're in this cave kind of deal. You can see up. Can't really get out anywhere from there. I think we can go that way. Oh, we can go that way. Alright, we're just going to play games now.
How are we doing on downloading it? You getting it?
It's a gig and a half download, so I imagine it'll take a couple minutes.
Cool. 7%.
Yeah. So we can see this is it's a basic game. This is actually supposed to be an MMORPG. If we will have a cyber server up later. But Aaron, do you have access to the Battelle server still?
Yes.
Okay, can you jump onto that? Okay. Gotta get something else working first. So some of us who went to Battelle have access to their server. We're going to set up our own, hopefully next week. And then we'll have more fun with the game then, because we can start exploiting the network protocol that it uses. So this is me, I'm Chris. Join. Pretty basic. I've got some stuff in my inventory. I've actually just walked out of the cave that we were in earlier. This is just the start town. Alright, so we can walk around, and there's not actually a whole lot you can do in this game without starting to exploit how the game behaves. So the nearest actual challenge is pretty far away. So just some basics about the game. You can jump, move around. You have weapons that you can flick, and it apparently kills your client. Oh, okay, there it goes. Wow. You got like the spells that it uses mana. There's a couple different ones. You got this laser beam. Wow, that looks lasery. Might be cool. There's also guns in this game, which is pretty common for a lot of online games now.
Substitute observation.
Yeah. We're gathering information. This is the information gathering portion of this exploit. There's a path that you can barely see on the ground, but you can follow it. And we're going to go steal some treasure for some bears. This will just take an unbelievably long amount of time to walk over.
Show how to hack the speed.
Speed?
Yeah, show the speed hack.
We're not there yet. We gotta get to the bears.
Man, this is the information gathering.
Information gathering. We're seeing how this system works. I guess we could open up Wireshark.
Huh?
Let's open up. Whoa. Ooh, what'd I do? Who's duck point?
So you'll be able to operate him.
Are you getting attacked?
Oh, you gonna die.
Oh!
Oh no,
Oh, the rat.
rat got
Damn
me.
rats.
Alright, we're going to open up Wireshark and just take a quick look into what the game's doing on the network. So we are communicating to a server right now. You guys will not be able to do that unless you went to Battelle again. Should have gone to our outreach. Wireshark will apparently have an error. Just ignore that. Ports. So this game operates on ports 3001?
It's just 3,000.
3000 and 3006.
Yeah.
Oh, wait.
One of those.
2005.
I thought it was.
3002. I found it. It only took a lot of effort.
I saw that in the code.
Alright, so here is the actual information that we're sending to and from the game server over the network. If we click on any of these packets in Wireshark, we can see what looks like random data down here to begin with, but we'll move into that and see why it's not. One more thing, if you're doing this in Wireshark, I don't know if you guys can see with laser eyes. Over here, this has some weird protocols listed, IPA. This game is actually entirely on TCP and IP. So what you want to do is go into enable protocols under analyze and hit disable all. And just add in IP, IPv6, and TCP backend. It's scratching my computer. Oh, God. TCP. IP. No, that's not right. Apple IP over IEEE. Okay.
Is that standard?
Is it?
I've never heard of that one.
We want IPv4 and IPv6 because that's how networks work. Okay. Where'd our capture go? Is the game still running? I've died. That's the issue. Oh, I broke it. Keep scratching it. Change ports? This is weird. Okay. Does someone see what I've done wrong? I don't inherently know.
Try 3005.
3005, okay. It's one of these.
Okay, then it might just.
No, I apparently have no data going through Wireshark. That would be an issue. No. Ah, there we go. I forgot to enable Linux captures. That didn't fix either. No.
Did you download the one for Linux? Did you download the one for Linux, sir? I'm downloading one for Windows. Oh.
It's not super pertinent that you do the one for Windows or Linux quite yet.
I got the one for Linux downloaded here. Where's the executable?
Executable? It should
Resources?
be the launcher.
I had it, no problem. when I did this last time.
I mean, you might just have to make it executable.
What am I missing?
Well, no, I could see that. I would like to just see.
Here's the stuff. Alright. Guess I don't know my filter is good enough.
Yeah, no, this is Pwn Adventure.
light scroll. Alright, so here's the packets that the game is sending out in live. You guys good?
We're figuring it out.
Okay.
We're gonna figure this out.
That second file was the executable, just the data, and then
We can see the more we do stuff, the larger the packet length becomes, which means it's probably shoving a lot of game or messages it's sending to the game all into one TCP frame. It can be important later. It's not whatever protocol it says it is. It's just plain TCP. You'll have to trust me on that.
There you go. Mission accomplished.
Rip? Okay. It just died. Again. I'm just going to filter out the game server here so we can see the traffic. I don't know why my TCP filters aren't working. I'm going to hit auto scroll. So we can see it doing things like attacking. Let's go back. Again, it's sending different amounts of information over the wire. This is where the attack started. This is where it stopped, and possibly other updates in between. So we can assume that the protocol is shoving a lot of information into one packet and then just sending it to the server. So what that means is it's probably loosely structured, which means that there's probably opcodes preceding certain operations that it sends to the server. Things like where the player is and what kind of attack you've made are probably only separated from the rest of the information by a prefix of some kind. That's just an assumption about the protocol. So we look further into here, we can also see on this attack packet where I clicked, there's the text static link in the body of the TCP message. That's plain text, and it actually corresponds to exactly what this spell is called, which is static link, so we know that the protocol is also not encrypted, which means we can do a whole lot of things after that. We can do all kinds of stuff like replay. We may as well just send that we're attacking everything on the server all at once forever. So because there's no encryption, we can just hook into it with Python. That gets weird. Okay. So let's explore that a little bit further. Has anyone gotten this downloaded yet? No?
Ours is still on checking for updates, so.
Checking for updates. Is it downloading updates or just checking?
I think it might be downloading updates, but it says checking for updates.
Alright.
We'll see.
Okay. We'll explore the game binaries a little bit further then. So when we ran this, we ran the file called Pwn Adventure 3. We can see that's just an executable ELF file, which is pretty standard for programs to be. However, we also know that's the launcher. So what we want to do is do some magic and just look at what the game downloaded. So if we recursively list all the files that we have in the game and ignore all the crash infos from me playing with it at 2 in the morning, we can see there's only a handful of directories that really matter. We have config, we have packs, which we can assume to be something like assets and resources for the game. We have something called server, and we have, where the binaries go? Oh, we have binaries. Linux. Oh, they're up here. Okay. So we have some actual code down in the data folder, but it's like 4 directories deep. Oh, I didn't go up by one. Yeah, there's other shared objects too. This looks like, oh Jesus. OpenAL Steam API? What? Interesting. Those looks like external libraries that we don't really care about. The most important one on here is libgamelogic.so, because we can assume from the name and from the fact it's a shared object library that's being imported into our game in some sort, and that's probably where the good stuff is. We can also see there's another binary in the same folder called Pwn Adventure 3 Linux shipping. We'll explore that in a minute. Pretty much everything else, though, looks like just a shared object library, which we could go through and try to execute each one, because shared objects can also have entry points for actually execution, but that's just not the case with these ones. We could manually test that, but it would take a while. So let's go to this folder. So if we list what kind of files are in this folder, we have several directories of crash information, something I was playing with earlier. We have libgamelogic.so. SO is shared object. That's similar to a DLL in Windows. It basically means a big chunk of code that gets imported by another program at runtime. That's an L64-bit shared object, which is exactly what we expect it to be. That means it's running on 64-bit systems. It's a shared object file. More importantly, we can see it's not stripped and it has debug info. So what that means is, without doing a whole lot of reverse engineering, we can find out a lot about the internals of this game pretty trivially. Oh, my battery's low. Let me get my laptop charger. Yeah.
It's down already?
It's down already. The big beefy laptop.
You charge this
I have that charger, so I was
Get your charger!
Yeah, this game upsets my computer. Ooh. All right. What else is there? We can also see there's another executable in this directory called Adventure 3 Linux Shipping. That is not a shared object library. It is dynamically linked, so it will be looking for other SOs to basically import at runtime. And even better, it has an interpreter, so let's go ahead and try to run that. It's giving us stuff. UE4.
Unreal Engine, probably.
Unreal Engine.
I think I saw a few tags for it when I was
Yeah.
looking at it there the other day.
So we've gotten some kind of window to load.
Right.
One day it'll load. Is it loading? No. My computer does not like to render anything from this game, so unfortunately starting it takes a while. Okay, so we can see just by running that binary directly that we have actually foregone the entire launcher system and just run the game directly, which is going to be important in a little bit. What else we can do is, because we saw earlier that it is sending network traffic out, we have a network proxy running. Basically, this is running in Python. I can distribute this later. And all it's doing is it's taking in connections from our game, and it's sending them right out the wire, and it's taking notes, you guys can see that, with how big the packets are, and there's actually, oh my god. It's a mess. Okay. There's nothing on here yet, but I've already set this up, so just take my word for it. These are the lengths of the packets we're sending out. There are a handful of packets that it knows by name. Yeah, I should just jump into this when I'm doing. Parse. Okay. And when we get data on the wire, we're going to shove it through this parse function. We're going to try to look for a prefix. I mentioned that earlier. If you stare at these game network packets long enough, you can see the prefixes very slowly and painfully. But basically every packet will start with, for example, when you move in the game, it starts with MV for move. Pretty basic. So we're going to have a list of handlers up here in an enum. Here's some of the prefix codes. This is in Python 3, so if anyone has this original code from Python 2, it looks a little bit different. We can see MV, I've already defined a couple of these, stands for movement, so position handler is what we're going to feed that into. We've also got JP for jump handler, S equals for switch handler, switch weapon handler. That's when you hit like 1 through 9 on your hotbar and your character switches weapons. Run handler is for when you sprint or not. XX is for entity delete, and star I is for attacks. So, if we go ahead and run that, and we dump all the information about movement to the console after deserializing it, and we open the game again, which takes another 5 minutes. One day I'll know not to close the program. Right. While that's loading, we can also start inspecting our shared object file that was in there. libGameLogic. So it's a shared object, which is similar to a DLL in Windows. It just sucks it into the program, and it calls functions. Our main program will suck it in and call functions that are stored in it. It has debug info, and that debug info has not been removed. So we have full symbol names inside of that. In Linux, the nm command will show you the symbols from object files, so shared object file, for example. And we can also ask for help. Go ahead and run that on our libGameLogic file. And we get all this crazy stuff. If you're familiar with how C++ actually compiles, you can see a crazy amount of symbols, and then what looks like a class, and then another couple numbers, and then some kind of function, and then the word function. Oh boy. So in C++, that means it's been mangled. There's just something the compiler does to make everything a little bit more uniform when it displays in memory. We can give nm the -c. So the -c flag.
What would it look like if it wasn't mangled?
Well, this is called demangled, so let's find out. It looks exactly like that. So this is a little bit closer to C code already, or C++ code. We've got std::. So this also tells us that the game has been written in C++, which means we can do a lot of low-level engineering, or reverse engineering, pretty trivially now. We've also got master server connection, game API, and a couple other classes are up in here. And I've actually got this command string filtered out. Oh, where am I pausing? So I went ahead and I made this command string that should show us a little bit nicer what the classes in the game actually are, just by graphing out some of the standard C++ stuff that we don't really see. Oh, it loaded. So we got game API, server connections, everything you would expect to see in a basic game. Inventories, heap sprays. So these are all classes that we can actually pull out later, and got to use GDB to do that, or else it gets really messy. So if we open this up in reverse engineering tools like Ghidra or IDA, we can actually export headers for a lot of stuff, especially things that don't have symbols taken out, because we can see their basic names. And if we actually open this in GDB, oh, that's not right. We can do the p-type command, but
For anyone who doesn't know what GDB is, what is GDB?
oh, GDB is a new debugger. It lets you debug applications. It's pretty advanced. It's got a lot of commands. We're just going to use the p-type for now, which prints the type information of whatever handle you give to it. Because this is a game, we can assume we have something called player or similar, so we can actually tab complete this, and that's a lot of information. So let's just start typing. We can see we do have something called player, so that we can assume that's going to be pretty foundational to how the game operates. So let's go ahead and see what's there. So we can use GDB p-type player, and it basically gives us the entire class of the actual player object, which we can then pull out and copy and paste into a C header, and then try to compile and link against. So we've got some protective functions. We've got, go up. You can see it's extending other classes, so we'll probably want to import those as well. And if we stare at this for about 3 more hours, we can actually pull out a whole header file. I've gone ahead and done that already because I didn't want to do it from scratch. Oh, it's not here though. It's in the other one. So after, going through all those classes and putting them into a nicely formatted C header, we get something that looks a little bit like this. There's actually one of these available on the internet. If you look up libgamelogic.h, someone else already did this, and we can get a lot of structs and information out of the game pretty trivially. Without going too far into that, let's go ahead and find the class player. So here's the actual header of the player. And if we look at it, we can find some interesting stuff in here, such as internal variables, but also external functions, such as can be damaged.
That's a bull.
What?
So we might want to flip that value.
Yeah, it's a boolean, so maybe we should try to find a way to make that always return false, so we can have invincibility. Damage, which is probably how much damage or applying damage to the player. Let's see, can jump. If we set that to true always, we can probably get some kind of primitive flying hack into the game. His local player is probably server related. What else? Is PvP enabled? We probably don't want that on for ourselves, but if we get really crafty and start exploiting the server, we could probably flip other people's PvP states and kill them instantly because they wouldn't be expecting it. Something fun to think about for the future. Let's see, what else is there? There's a lot of operations involving inventories and items. There's a get mana, so if we can get in front of that and make it always return, say, 1 billion or 100, we'll basically never run out of power for our spells. Use mana is the complement to that. It'll probably just do nothing if we can get in front of it again. Picking up items and setting down items. Some quest state information, so maybe if we want to, we can just say, hey, we've done all the quests in the game, give us the points. All kinds of stuff. So this is interesting because a lot of games, like AAA games, sometimes will even ship with a lot of debug information on their game files, usually through error.
Dead Island, right?
Yeah, Dead Island did this. I think.
Fallout 76.
Yeah, Fallout 76, like the very first version of it that came out, like the production build, had all the debug symbols on it, so you could do the equivalent of what we're doing in Windows and just basically pull out the header file and compile shit back into it.
I think all the traffic was unencrypted as well.
Was it?
Mm-hmm.
Ooh, that's a bad one.
Fucking
Yeah.
awesome though.
So we'll actually get a little bit further, and we'll find out that even if you can encrypt traffic, we don't need to reverse engineer your encryption to make it do stuff. Let's see, what else is there? There's a function called teleport that could be interesting. Perform teleport. So it takes a string. So there's an interesting mix of car stars and STD strings in here. That could potentially be an issue because it usually a developer will use one but not the other. There's not a whole lot of reason to mix those. So this might be an issue with GDB, and if you've used GDB a lot before, you've maybe seen this already. Car stars and STD strings, it's really hard for GDB to tell which one's which. Interesting. Especially if you pass them by reference or as pointers.
I mean, in the low level, aren't they just characters anyways?
No. String is a class, so...
Right, within that class.
Yeah, within that class, it maintains an internal car star, but the string class itself is bigger than a pointer.
Right.
So that can potentially be an issue if we're dealing with memory offsets, but we should be fine for now. What else? Alright. Submit DLC key. That might be something interesting later. Mark as achieved. Again, if we can find all the achievements in the game, we can just iterate over them and say we have them. Yeah. Respawn. Perform teleport. You're going to throw that. Chat. Perform chat and receive chat. If we can hook into functions like that, then we can actually, through the game's interface that it already has available for us, develop an exploit for the game and then interact with that using the built-in chat system. So if you've ever installed like a mod on a game, you may have seen that before. That's a pretty common thing to do. To add like a / commands and then not send them to the server so everyone can see what you're doing. Because this is on our box, we can control all the code execution. And because we have the header, we can control it almost trivially by buying new C++ flag, or new C++ for it. Can I quit, please? Alright. So we go back, we have, not here. So we have our proxy running, and it's going to be printing out all the movement information in the game. And we're actually impacting these from structs because it sends them as MV and then 3 floats shoved together in byte representation. So that's just a little bit of the internal Python for you. So most of the information this game actually sends out is pretty trivial in terms of how it's encoded. There's no depth to it. Beans. Yeah, that's not my password, don't worry. Join. Alright, so we can see, even if we didn't know that how the data was encoded, we could just try to decode different things out of it. We're not moving. We shouldn't be moving. But as we do, we can see these numbers start to change. They're kind of flying by pretty fast, though. So we're sending a lot of position updates to the server, which is pretty typical for online games, because most people, if they're shooting each other, want to see where everyone is. We can actually potentially use that to our advantage if the server is sending us position updates with other players. And for most games, hit detection is client-side, so we can just say, yeah, we shot everyone that we can possibly see, all at once. Headshots. So that might be something we want to explore later. For now, I'll go ahead and close this. We'll move into how we can exploit some stuff. I didn't want to quit that. Right. We're all in one window now. So if we go back into our... We have our header here. We need to test and see if we can compile against it. We don't actually need the SO present to compile against it. We only need the header, as long as we compile in a shared format. So this is going to get really interesting really fast, and you have to know a little bit about how memory is loaded. But if we go back to, not this one, I'm skipping information. LDD, or nope, LDD. What is LDD, you ask?
What is it?
Oh my god.
What
What is
Clear.
LDD?
What is that?
LDD is a utility in the bin utils package, which is on every Linux system ever, that prints shared object dependencies.
What?
We're going to find out why that's useful
LTD.
immediately, because we can run it against our actual game client, and we can see something interesting is that it's importing crypto but not using it.
Of the SSO.
Where'd it go? Where's game logic? There it is. It's importing the lib game logic. So, if we can modify the behavior of our lib game logic DLL classes, then we can modify the behavior of the game. Alright. That's what I was trying to say. So, we go back over here. Test. Header compile. We can do something easy to start out with. Because we're pulling all these classes out of GDB, we got to make sure we have them all. So probably the safest way to do that is to just compile. Obviously, we can go back and compare with NM what symbols we do and don't have until we have what looks like all of them, and just slowly grep out the ones we find. Excuse me. So if we can compile and run this, then hopefully it works.
Yo, you gotta use GPP or GCC, buddy.
It's in C++.
Nah, man.
You're wrong. Alright, we can see it works. So what can we do with that? Because we have direct access to what the game's memory layout should look like through the header file that we generated, we can start to do more interesting stuff. So there's this thing in most operating systems called preloading. So before you load stuff into memory to run a program, you can say, hey, load this arbitrary file instead of what you're about to do, and then do your stuff. In Windows, it's not how most game hacks go. Usually people do DLL injection, which is after you've already loaded everything. But what this lets us do is get in front of the symbol table, the VMT, in C++. So whenever someone calls something, looks for a function, for example, player get jump state, it will find our symbol in memory first and then execute that. So in Linux, we do this through something called LD preload, which tells LD, which is the library dynamic linker in Linux, to load our library first before it even opens the game executable. Cool, that was a lot. So we can start with a pretty simple function. So like player get jump state. Its input is a single bool called state, and all we're going to do is printf that to the console as a 1 or a 0. It's a decimal. Okay, Boolean to decimal. That's fun. Let me undefine some stuff real quick. Whoa. Okay, we'll get to those later.
My dad works for Microsoft. I'm gonna report you for hacking, man.
Alright, I'm being tackled.
Dude, some of those kids aren't lying, man. I got my MW2 account reset from my 10th to level 1, some little squeaker.
Alright.
I never expected it.
Okay, so we need a couple more fun flags now. The first one is called shared, which basically means we're not going to create a straight executable. We're going to create a shared object that will be loaded into memory by another program. What we need to load after, the next flag we need is called fpic, which says we need to format our assembly as position independent code, because we're literally just going to shove it into the memory table, and we don't want it to have absolute offsets. If you know assembly, you know that most jumps have just the actual definite memory location. This will replace the definite memory location with relative jumps. So it's safer, but it's not at the same time. But we don't care about it being safe, we just want it to work, so that's how we get it to work. So we say build us a library called ldpreload.so, or test preload.so. So we built a 64-bit shared object. It's not executable, it's dynamically linked, and it's not stripped, so we can see debug information of our own, but that's not a big deal. So, how do we get that into the game? I already said it several times, we want to do something called LD preload. Oh, closed it. It's gone forever. Binaries, Linux, okay. Alright, so the way we do that, let me back up. Oh god. is by interacting with the LD executable, which is in Linux, and basically every time you run a program, this program gets called to load your memory in place. So it has something fun called LD. Oh my God. No. I don't know why it's not showing it in the man file, because that's where I found it the first time, but I'll just explain it here. We can give our program, or really the Linux environment, a environmental variable called LD preload, and that can just be a list of shared objects that we want to shove into memory before we even open our program. So what that looks like is LD preload equals the absolute path, probably also be relative, to our shared object file. You can do a similar thing in Windows through a registry key called app-init DLLs. However, that will not just do it for the program you're trying to start. It will do it for all programs that run on Windows, so that's actually a pretty common malware entry point vector. So, what we want to do is load test preload and then our game. So we already saw Pwn Adventure Linux shipping was our actual game executable. So let's see what this looks like when every time we jump or set the player jump state boolean, if we just print it to the console. Let's see what that looks like. Let's go over here. Our screen breaks, as it should every time we open a program.
Yeah, right. Your screen ain't breaking.
You're doing it wrong.
You ain't happy.
Yeah. My laptop is not like the Unreal Engine.
In the industry, if your shit ain't broke, it ain't working.
Thank you.
Yeah.
Alright.
Over guys. Got you.
I can't even see the buttons. Okay, we need to be able to see this window, so I'm going to leave this right here. There we go. So I just jumped 3 times right there, and you can see that it does 2 actions for every jump we do in game. It sets our jump state to 1, and then it sets our jump state to 0 when we stop jumping. Excuse me. So now that we can see that we can actually manipulate the code our game is running, we can do a lot more interesting stuff because we have... Are you leaving?
I got to, yeah.
You have to leave?
Yeah,
Where are you going?
elections for board game.
Board game?
Yeah.
Priorities.
I'll be back.
This is important.
It is important. And I downloaded it, and I actually
Yeah, but you're missing the important part.
This is the cool part.
Alright, it's cool.
Rip you. Alright.
We got live stream.
Get out of here. We need...
That'll be online.
I am Gamely, it's my name.
If you can see it. You can see pretty well on the live stream.
Alright.
It's not that bad.
Are we not using the, like, screen inputs I've got ready for the live stream?
No,
It's broken.
it's broken, so that's why
I thought we just fixed it.
that's why I've been moving the camera.
Is it plugged in?
Yeah, it's plugged in. It's just not.
Is it?
It's working. We're good. We're good. Alright.
Okay.
Ooh, Chris. Ooh.
Ooh, thanks. I hear some fans in the back.
Just don't get your beautiful face.
Alright. So let's try to do something simple like jumping forever, which can give us a kind of primitive flight. So let's go ahead and exit the game safely.
You the man, Chris.
What?
You the man.
Thanks. So I've actually already kind of added this to my preload output real quick. So we've got something called flight mode. If we go down to it, the most important thing it does is it says we can always jump. So can jump is always true. In the actual game, it probably we didn't ever disassemble it. It probably looks for if you're already in the air. And if you're already in the air, it's probably going to return no. But if we're already in the air and we can jump, it's going to do some interesting things. We've also got get jump hold time. Without going super deep into the code base, this ends up being how long you can hold the spacebar and still continue to go up in the air for. And then we've also got get jump speed. This is actually looking a little bit low, so let's go ahead and add some zeros to that. So we'll just do one of those.
Maybe Saturn V rocket up in
Yeah.
space.
I don't know how
Oh,
fast
it's
rockets
so
are,
cold.
but I hope they're close to this.
Do we have shared object files in real life?
Books.
Can I edit my header file?
Alright. So let's go ahead and recompile that,
Only in the virtual
and we'll see
reality.
what the effects are, as it takes another 5 minutes to run
It's
our
like the one
game.
guy.
So we LD preload the new binary that's going to modify how our jump behavior is. And we'll open and then make my computer steady again.
Have you set the jump speed to that high before?
It's going to be important in a minute. You'll find out why.
Huh?
Yeah.
Yeah?
It goes zoom.
Yeah, I was gonna say, are we gonna clip through the cave?
We're going to explore some stuff. This is what time is it? 7:30.
7:26. You get your time.
We'll wrap up in like 10 minutes. We'll just see what this ridiculous jump speed does. That 10 minutes is just going to be the game opening.
Do y'all know the reference to that? Ghost in the Shell Code?
Ghost in the Shell Code.
No. You know the reference?
There was a movie based on that, I think.
Ghost in the Shell. It's an old
Let's do
anime movie.
offline so my computer doesn't like actually die. And just a little faster. Oh god, we can't do this offline because I'm
And
not.
it's also playing on the, I think it's also playing on the book Ghost in the Wire, which is written by, I think,
It crashed.
Ackerman.
Okay, so because we've started playing with memory, the more things we add, the more unstable the game will become. As you just saw, going through menus too fast apparently crashes things now.
Fucked up.
Yeah. That's because that huge header file that we dumped out through GGB manually earlier actually does have some incorrect sizes in it. Most of them are actually the strings and the car stars. So when we look for something in memory, it's not always where it is, and then the game gets upsetting, extra upsetting. More upsetting than taking 10 minutes to open. We'll just fly up in the air and see what we can see. Is that your neck?
That was my neck.
Ew.
That hurt.
You might want to overload that net cracking function.
Yeah.
Just check it out.
Okay.
Play game. Alright. Something else to notice is that the mouse pointer position was reading perfectly fine earlier, but since I've started preloading stuff, it's about a quarter of an inch above where it should be, or below where it should be. It's kind of a weird side effect of
Why does
starting.
it say live overflow on your login page?
Yeah. What?
Why does it say live overflow on your login page?
Okay. So let's try out our new flight mod. The screen goes black because we just shot up so fast the game can't render what's happening.
Please text me.
This is
Pretty
great.
big ones.
Mine is
Wait,
weird. I'm trying to get a map of the game just by flying straight up, so let's see if this actually works. If it doesn't, we have to recompile.
Oh boy.
Alright, so let's just go ahead and kill that, and then drop a couple zeros off of that number.
I'd like to know how many theoretical G's we just pulled doing that.
We gotta recompile. I think we just touched the moon, is what just happened.
I don't know, man. I think we're up and out in alpha.
I think the game just straight up stopped rendering because we went up so high. Yeah. So we can see that we can at least modify what our client is doing. Because our movement is just kind of inherently trusted by the game, and this particular game does not check it at all, we can actually know that the server sees us doing the same thing, just shooting straight up in the air. Which means this is also server-side behavior, which is the important part of hacking a video game or any kind of service on a network. Is you can do anything locally, but if you can get it to happen on a remote machine, that's way more impressive. Oh, I didn't click that one. Alright, let's see if we're still in the atmosphere when we log back in. So got a slightly more reasonable jump speed now. And we can see I've let go of the button. We're going to start falling. Because our set jump state is, or our can jump is always true, I can just hit the space bar again and hold it down for however long I want. We'll just kind of fly straight up. So we can actually get a pretty good map of our island if we just hold down the space bar forever. The computer will just get progressively more upsetty. So, you know, there's a whole lot of stuff to do in this game. Fly hacks is just one of them. But not recommend a fly speed of several thousand unless you want to get a map of the game. So, yeah. Any questions on what the fuck I just talked about? No?
The map is shaped like a pony, but it's upside
The
down.
map is which way? That way?
Yeah, that way.
Kind of looks like a horse, yeah. Alright, we're flying straight up in the air so you can see there's a dark mass over there. So there's actually other hidden stuff on this game, like other islands that you can't actually get to. So, yeah. If you can implement a speed hack, you can probably fly over there. Alright.
Can you go that island?
Yeah, you can walk there.
God damn.
I didn't have the speed hack in.
This is 5,000.
I got over there Monday night at 1 in the morning. Yep.
Holy shit.
It's 5,000 speed.
Just reminds me of COD 4 getting out
Can
of
you
the
jump
map.
again? Or
Yeah, you can jump forever. That set can jump. Player phone can jump because we always return true. Even if we're in the air, we can just right up in the air.
so I mean, if you get space again, would you just go shooting up a very high amount right
Yeah.
now?
So watch the where the edge of the map lines up with the the words at the top of the screen. If we hold spacebar, we just go right back up. So if we set our jump speed like maybe another magnitude lower, we could actually control it pretty nicely. I think I was running with like 250 the other day. It was actually pretty reasonable.
I like 5 billion better.
5 billion? Yeah. Alright, that is all. I encourage you all to have some fun with this game over the next 2 weeks. Are we meeting next week, Cliff?
We're not.
Okay, so we're going to try to get a server up for Cyber UC purposes too, instead of piggybacking off of Patel's.
Don't you mess that up again.
So, yeah. Thank you.
Alright.
You can do other stuff to this game too. You don't just have to LD preload. You can patch the actual game binary directly, and you can do all kinds of network stuff. This is just one example of an attack vector. Right.
Dude, we might just make
Alright, that's gonna be it for today. Thanks for coming, everybody. No meeting next week, so probably shouldn't come, because no one else will be here.
You can if you want.
Yeah, you can. I mean, yeah.
No, I study a lot in this room. Like, it's my go-to room for study.
Alright. But yeah, thanks for coming, everyone, and good luck on exams.
Someone should write a script that just sits and watches your Steam games for updates and if they have symbols on.
Yeah, I don't know if we're gonna end up doing that.
Nick has a name.
What?
Nick has a name.
Are you supposed to be original?
Somebody's